Hey everybody, hope you're having a great web summit. So we're here obviously to talk about the web. You might know Mozilla. We're kind of known as the guardians of the web, the defenders of the web, the protectors of the open web. I work on Firefox, and we maybe have a slightly different perspective from that psychology. We build the web, and the way we build the web is through a browser. To understand what it's like to work on a browser, to slip into the mindset of a browser developer, the best way to do it is to think of yourself as building a supersuit. This is our internal mascot. We've never ever shown it publicly. When we build a browser, we think of it as building a suit that a user puts on to go do amazing, wonderful things out in the wide open internet. The suit's got to have rockets, it's got to be able to fly, it's got to go super fast, and it's got to keep you safe. We build supersuits. So quick aside before I get going here, this talk's really going to be about what it took to build a new supersuit, as opposed to what the suit actually is. This is my 5th day on a European press tour. We have a big launch of Firefox next Tuesday, right? Biggest release we've ever done. The punchline is right here. It's super fucking fast. The best browser we've ever built. Probably the best browser anyone's ever built. And the same question I get 5 times a day for the last 5 days is, how do you guys possibly compete against Google? Right? I just heard this conversation over and over in the lobby. Everyone's talking about it. The only folks on earth that can build big software products anymore are the big 5. How do you do it? And then they usually ask about our sliding market share and how Google now owns the browser market. And that's true. And I say, you're overthinking it, right? It's not really about viewership and attention hacks and all kinds of crazy stuff. It's really simple. Google built a better browser than us, and they kicked our ass with it for about 5 years. And so the way we're going to kick their ass back is building a better browser that lets users do more and have a lot more fun on the internet. It's just really that simple. So first step, how do you beat Google at browsers? Number 1 step, you run a giant billboard across from their office and make fun of them. That's one way to do it. That's where you start. If you can't tell, all the teams in the world that build browsers have a lot of fun. We all know each other. We're all ultimately trying to build an open web. Maybe just the motivations of the organizations that employ us are a bit different, right? Everyone gets that Google is an advertising company, so they build a browser to protect that business. We build a browser because it's the only thing we do. It's how we get to implement the web. But we all really believe in an open web, so we get to have a lot of fun. So why are we cocky this time, right? There's a new version of Firefox every 6 weeks. We don't run billboards every 6 weeks. The answer is, we kind of disappeared for a while, so we'd get the right to come back. And so on Tuesday, we're going to release a browser really that we were not able to build any time in the past. This is really the first time we could build a browser like this. And so we're cocky because about 10 million people are running this browser in beta right now. And here it is, never seen before, an entire wall of positive tweets. It can happen. Of course, the number 1 reaction we get when someone tried an early developer build of the new Firefox was, holy shit, it's fast, which is exactly the thing I wanted to hear. We've gotten some nice press headlines. Really, the thing that really makes us happy is when we have longtime Firefox users from 5 years ago that kind of gave up on us, maybe when we were a little bit slower, a little jankier, switched to Chrome. They give us a shot, and they pretty much now universally can't believe we've somehow done it again. So what actually goes into a browser? I'm going to go on a slightly high-level technical journey for the rest of this talk, because there's lots of other places you can get information about money and how competition is for losers and advice like that. I like competition. I'm also going to give you, hopefully, 3 gifts by the end of this brief 15 minutes we have together. So we kind of have a secret power when it comes to rebuilding browsers. Namely, we've done it before. So Firefox 1.0 was in many ways the rebirth of a browser. Right? If you don't know ancient history, I'll quickly remind you. Our code base goes back over 20 years, which in modern software and certainly internet time is essentially forever. Amazingly enough, 19 years ago, almost to the day, Netscape announced that they were switching to an entirely new rendering engine, and it was going to be amazing. That rendering engine was going to be called Gecko. The rest is mostly near or total disaster, depending on how you look at it. The high point is, no joke, the announcement of switching rendering engines and then a precipitous fall. Arguably, the product and engineering teams didn't really recover from the decision to completely swap the engine until Firefox 1.0. So it was a long time ago, but catastrophes like that kind of stick in the back of your mind a lot when you make a browser, because you remember that a browser has to render every single web page ever written. It's a little bit complicated, and if you start letting yourself think, oh, I'm just going to make a new one, it'll be fine, you're probably going to have a Netscape experience, and it won't end well. But we knew the architecture of Firefox really hadn't been touched since the first Netscape design, right? Single process. It's basically a cooperative sharing macOS style, original macOS style approach. And so we knew the architecture needed a massive overhaul. The Chrome team knew this, right? Chrome was started by Darren Fisher, an ex-Firefoxer. I think 10 of the first 11 Chrome developers were ex-Firefoxers. They knew the challenges from the Firefox architecture. They tackled them in Chrome. They split things into multiple processes. It's now famous. It's been kind of imitated by every browser that's followed. You create a process per tab, and that way a site sits in a tab, and it can't slow everything else down. Pretty obvious that we should do that, right? Why don't we do it? Just do it. It should be easy. Well, there's a problem. For us to copy that approach would essentially break everything. Really, the browser was never designed originally, Mosaic, Netscape, Firefox, to be built like this. You kind of have to start over to do it, but we have that problem. We can't start over. The solution came to us at about 5 years ago, after, honestly, about 3 false starts. A thing called cross-process object wrappers, KPOWs, as we came to know them. Super boring. No normal user is ever going to know about them. And in fact, they're now completely deleted from the product. But they were key to let us go forward, because it meant we could start to refactor the code base to go multi-process while not breaking any of the single process add-ons or even primary user interface of Firefox to get there. So once we knew we had a path to reinvent the browser, we started to ask questions. Just like Chrome could learn from Firefox's design goodness and badness, we could learn from Chrome's good and bad. We knew if you ran on a $3,000, €2,000 MacBook Pro, using a lot of processes makes a lot of sense. Probably an unreadable slide. We also know from the 500 million user sample of the world that we have in Firefox that normal people don't run 2,000-pound laptops. In fact, the exact median laptop that most people in the world run is a 350-pound Acer. Everything else is almost noise at this point, right? So we know how much memory actual laptops have. We know how many CPU cores they have. What did we do about it? We made a pretty early decision. One of the things we'd figured out in Firefox was how to do multi-threading really well. We had to, because we didn't have processes. So, necessity is the mother of invention sometimes. What we now have in Firefox is the ability to create processes for isolation and performance when we need them, but the ability also to retain containerization through threading when it makes more sense. And so the end result for us, we hoped, was that we could pick and choose in the product where, when we needed to run parallel code or run asynchronously, whether we were going to use a full process or whether we would stick with threads. The goal, of course, was a better balance. We wanted high performance, we wanted safety, we wanted sandboxing, but we didn't want to do it at the expense of ruining the ability of a 300-pound, 300-euro computer to have 50 tabs open. That was the first piece of work. It started about 4 years ago. It finished about a year ago. A lot of people have asked, like, well, why didn't it get done sooner? This is the answer. It's a 20-year-old, 8 million line code base. By the time we were done, we had touched 75% of that code base, 6.8 million lines of code changed. It took us a little while, I'm sorry. But it's done. And here's the benefits of this in the real world. On anything more than 3 tabs open, Firefox saves you about 30% memory compared to Chrome or any full multi-process browser. And it does it with all the security and performance guarantees that you can get from a multi-process model. Works out really great. This was the first big thing for us to do. We had to get this out of the way, but it didn't really make the browser inherently faster, but it was a good foundation. The second thing we had to learn was science. Our culture predates AWS. It predates message queuing on servers. Practically, it predates A/B testing. Firefox is older than most of the techniques that are currently used in modern software development to make sure you're working on something and it's going to give you a good result. It took us a little while, and a huge thanks to AWS, for example. I don't think we could have built this browser before AWS, because it meant we could get the kind of data capabilities that a Google has without having to invent it all ourselves. We became world-class data scientists. We developed a rigorous, objective-based plan, 18 high-level metrics based on user research that were going to impact user-perceived performance, not just a benchmark win. That broke out into about 1,500 small bugs that were filed. And the big trick we did is we made it all public so that everybody that owned a component could be really ashamed of how slow and shitty their component was. And we gave them a target to fix it. In about 9 months, against even all odds that I would have bet on, we had closed the performance gap on every major user-perceived performance criteria, and we're starting to exceed Chrome on many. This is the kind of work that myself as an engineer, I absolutely love. It's not a whiz-bang feature. It's not a new knob. It's not really a new capability you get in a web browser. It's just cold, hard engineering, paying down technical debt, having your best engineers just sit in the profiler all day long finding slow code paths, and then having eager engineers, often inexperienced engineers, pick up those bugs and chase them until that little piece of code is fast again. And people noticed. So, major architecture update, kind of a religion around performance burned down, enabled by modern day data collection, data processing, insight generation. We knew that was going to be the base, but there was one more thing we really needed to do, and that was take everything we'd learned from the last 10 years of building browser engines and make a big leap. It took us a lot of energy to not go with a Ghostbusters pun again. If you know the Firefox code base, all the code names are from Ghostbusters. But I love Quantum Leap. It's really terrible but awesome sci-fi show from the 80s. We knew we needed to make a big leap, and we had just the thing we needed in our back pocket, namely a brand new engine from our research group called Servo. This put us right back, though, in the same conversation I started with, the well-overused engineering metaphor. The job is to replace the jet engines on the airplane while it's in flight. And so we decided we've got a creative solution to this. We're not going to replace the jet engines. That would be silly. We'll just replace the parts in the jet engine while we're at altitude. And so when you break a browser down into its component pieces, you end up with 4 major areas: rendering, composition, the document object model, components, and CSS. We kind of set an ambitious target to pick up a brand new CSS engine from our research group and ship it in 9 months. Again, we had a superpower. It's called Rust. Maybe you heard about it, maybe you didn't. It's a new programming language. Really, it's designed to replace C++, is the easiest way to think about it. It's a project that started 7 years ago at Mozilla because we realized as long as we were primarily in the business of slinging C++ code, in fact, Google, with much larger teams, was always going to have an advantage because C++ code, no matter how good you are, yields an amazing variety of terrifying bugs in its wake. And so it's really expensive to write. It can be fast, but it's incredibly expensive. Rust is designed to let us write the same kind of code and go for what we call fearless concurrency. Easy primitives to write concurrent code that we can mathematically prove don't have memory bugs at compile time. Huge performance advantages, huge safety wins. Servo, our research engine, is written in Rust. And Stylo, Quantum CSS is the marketing name, is also written in Rust. What does it do? For the first time of any browser, it means we can rip through CSS layout and start to parallelize it. So now that we not only have processes at the browser architecture, threading within those processes, we can actually start to multi-thread and parallelize the execution of web layout itself. Originally, we did this thinking we were going to at least get to on par, but it'd be a lot easier to maintain the code, and it'd be a great way to force ourselves to kind of take on all the work of bringing a new language into the code base. And so we were pretty pleasantly surprised when it actually started beating all other CSS layout engines. And it had an interesting property that the more complicated the layout in the page was, the more of a win Stylo delivered. So on the most complex web apps and web pages, we get the biggest gains. For Firefox, this was an epiphany. This was essentially the opposite of our previous state. Naturally, we had a new engine. We had this little thing called WebVR we worked on, which meant now we could do smooth 60 frames per second animation in the browser. And so we kind of couldn't resist putting a new interface on this thing. It's got a whole new look and feel. It's designed from the ground up around user-perceived performance values. It's got smooth animations. It feels fast. And while we're in there, we fixed a bunch of crazy arbitrary decisions that we had made a decade ago on where things like collections of bookmarks went. So now it makes sense. There's a page action. There's a library item. If you're going to work on the page, everything's in one place. If you're going to work on a collection of pages, it's in another. The whole thing's come together into an experience like this. So you can tell at Fire. We've been around a while. No trouble, right, to see we kind of love tabs. Big changes coming in tabs as well. We're going to finally give extension authors the ability to completely take over the tab interface safely. It's going to be wild times ahead in the world of browsers. If you want your tabs somewhere else on the screen, that's coming. It's going to be fun. So end result. Compared to 6 months ago, Firefox is twice as fast. That's good enough that I get to stand here on stage and say we're launching this thing on November 14th. But really, this is a race we're planting a flag now because we've got 3 more next generation engine components we're going to roll in 2018. And we're going to go for another doubling of speed this year. So look out. Browsers are going to get faster. We know the Chrome team is tooling up to give us a run for the money. It should be a great time to be a web developer and have web technologies embed in your products because the performance wars are going to get real, real fun. So where does it lead us right now? So that's the current state of browsers. Twice as fast in 6 months. I don't want to admit how much faster it is compared to 18 months ago. It's a bit embarrassing. But, you know, a number that starts with 6 would probably be about right. 3 gifts for you before I get out of here. 1, Rust. Give it a try. If you ever have to worry about C++ code, my apologies or congratulations. I don't know. I still feel awkward about C++. But give Rust a go. It's fantastic. Number 2, if it'll go. Dirty little secret, a lot of Firefox is written in Firefox. Namely, it's written with HTML and CSS and JavaScript. So all the tools we use to make Firefox twice as fast, you can use too. Last thing, you can download the beta right now. Give it a shot. There's still time to file a bug. We are on release candidate 2, but if you catch me afterwards with the bug, I will try to get it fixed by Tuesday. And with that, thank you very much. And just remember, it's software. Anybody can build good software, not just the big guys. Just go build what you want to build, and don't worry about what the Frightful Five are going to do. It'll be a lot better life. So, thank you very much.